we're solving radical equations today. And solving radical equations is very similar to solving the x squareds, like what we did for Bellwork and what we did last unit. So at the top we have some steps. So the first thing that you want to do is isolate the radical, or you want to get that square root by itself. Then we get rid of the radical by squaring both sides. So just like for our Bellwork, a square root gets rid of an x squared. So in this, an x squared gets rid of a square root. So raise both sides to the second power. And then we just solve for x. But in these problems, you can have extraneous solutions. So you always want to plug them back in and make sure that they work. And so an extraneous solution is one that works algebraically because of the squaring, but when you plug it back in, it doesn't work with the square root. So we'll look at one like that. So if we look at this first one, we have the square root of x plus 3 equals 5. So the first thing you want to do is move anything that's outside of the square root. So in this one, that plus 3 is outside of it. So how could I move it to the other side? Good. So subtract 3 minus 3 on both sides. So then we've got square root of x, because our 3's cancel out, and then 5 minus 3 is 2. So now our square root is all by itself, so we can get rid of it by squaring both sides. Okay, so just like our warm-up, square and the square root are inverses, so they cancel each other out. So then we get x equals, and then 2 squared is 4. Good. Questions? Yep. So then to plug it back in, you can just plug it back in your calculator. So you want to type it into the original equation. So square root of 4 now. Hit the over button to get outside, and then plus 3, and that gives us 5, and that's what we want. So we're good to go. Check. Questions? Let's look at 2. So on 2, again, we want to get this square root by itself. So what should I do first? Good. Add 5. So then we'll have 3 times square root of 2x equals, good. Okay. So then it's 3 times the square root, so how can I move that 3? Good, divide. So then our 3's cancel. So we have square root of 2x equals 2 again. Then, to get rid of that square root, square both sides. And then, good. So then we have 2x equals 2 squared is 4. Good. Good. Very good. So then our last step, divide by 2. So then we get 2. Again, you do want to plug it back in to the original, just like it looks. So 3 square root of 2 times 2, hit over, minus 5. And we get 1. And that's what we want. Questions? Alright, let's look at number 3. So if we look at number 3, again we want to get this square root by itself. So how can I move that negative 2 times the square root? Close. Divide. Good. So since it's times, we want to divide by negative 2. So then we'll get the square root of x plus 3 equals negative 6. So then square both sides. You are squaring the 6 and the negative, so if you type in your calculator, you type it -6 in parentheses squared. And we get 36. So both the negative and the 6 are squared. So -6 times -6 is positive 36. And then what would be my last step? You got it. So then we get 33. So then we want to type it in, make sure we get 12. So -2 square root of 33 plus 3. And I get -12. Do what? Yes. So I want it to equal 12, but it equals -12. Are those the same things? No. So then 33 does not work, and so we have no solution. Okay. And so the reason for that is when you're taking the square root, you're either going to get a real answer or you're going to get an imaginary answer. So it's always going to be positive. So you can never have a square root equaling a negative. So really right here at square root of x plus 3 equals -6, I knew that our answer was going to be no solution. But again, you can always solve it out, plug it back in, and it has to be exactly the same. Okay. So then 33 would be considered an extraneous solution. So it works because we squared it, but it doesn't work with the square root. Okay. All right, let's look at 4. So what should I do first on 4? So we want to move that 3, so we'll subtract it. And so the difference in 3 and 4 is that 4, it's 3 plus the square root. And in 2, it was -2 times the square root. So we divided on 3, but we subtract on 4. And again, it's because of that plus sign. Okay. So then we have square root of 5x plus 6 equals 9. Then what? Good. So we get rid of that square root, so we square both sides. Cancels that out. So 5x plus 6 equals 81. Good. Good. So now we want to solve for x just like a regular old equation. So subtract 6. Good. Good. So 5x equals 75. Our last step, divide by 5. Good. And we get 15. And then again, we'll plug it back in, make sure it works. So 3 plus the square root, 5 times 15, plus 6. And we get 12. And that's what we want. Questions. So hopefully not too terrible. Maybe. We're going to skip number 5, but let's look at number 6. So what makes number 6 different from these other ones? Good. So it has this x plus 3 on the other side, so it has 2 x's. So when that happens, what you want to do is first get the square root by itself, if it's not, which it is in this one. But we're going to go ahead and square both sides. Okay. So what happens now is we have x plus 3 squared. So I know it's been a couple weeks since we did this, but remember, that means we have to write this twice. And so then we have to multiply it, FOIL it out. So x times x is x squared. X times 3 is 3x. And then 3 times x is 3x. 3 times 3 is 9. Any questions getting there? So then we have some like terms over here, so we can combine the 3x and the 3x. So we'll get x squared plus 6x plus 9 equals 5x plus 29. And so now we have x squareds and we have x's. So when this happens, you're going to have to solve it with the quadratic formula. So to use quadratic formula, remember we want it to equal 0. So I'm going to move the 5x over, so subtract it from that 6x, and I'm going to subtract that 29 over. So then we get x squared. 6 minus 5 is 1x. 9 minus 29 is negative 20. And this is about as tough as these problems get. So we need quadratic formula, which was this. So negative b plus or minus the square root of b squared minus 4ac, and then everything over 2a. And so we've got a, b, c. So our a is what? 1, good. Our b is also 1, good. And our c, good. So then we plug it in. So x equals negative 1 plus or minus the square root. 1 squared minus 4 times 1 times negative 20. All over 2 times 1. Then, remember, we simplify each little piece. So we have negative 1, that doesn't change. But then we need to know what's under that square root. So you type just what's underneath, not the whole thing. So 1 squared minus 4 times 1 times negative 20. Like that. And we get 81. Over 2 times 1, 2. Go. Questions are getting there. I know it's been a couple weeks, but hopefully we haven't forgot it. So then, remember, we look at the square root. What do I know about the square root of 81? Yeah, it's perfect square. It's 9. So then we can say negative 1 plus or minus 9 divided by 2. And so since our square roots are gone, we can simplify this again. And we can say negative 1 plus 9 divided by 2. And negative 1 minus 9 divided by 2. You can just type that in your calculator if you need to. Or you can just say -1 plus 9 is 8. Divided by 2 is 4. -1 minus 9 is -10. Divided by 2 is -5. So those are our two answers for -5. But we do want to plug them back in and make sure that both of them work. But on this one, we have two sides. So the first side, if I'm looking at 4, 4 plus 3 is 7. So I need to see if this other side is going to give me 7. So 5 times 4 plus 29. And that gives me 7, and that's what I want. So 4 works. And then we check -5. So -5 plus 3 is -2. So then I need to see if this other side is going to give me -2. Is it? Because it can't give me a negative, it has to give me an I. So it gives me +2. Does -2 equal +2? No. So the 5 does not work. So then your only answer is x equals 4. Okay. So sometimes when you have two answers, both of them work. Sometimes one of them works. Sometimes neither of them work. So you just have to plug them back in to see. Any questions on any of them? I know this last one was a doozy, but hopefully the rest of them aren't too bad. Hopefully. Alright, let's look at the back.